Still in the surface treatments, module 8, we will discuss the general principles involved in any surface treatment. We are still in the surface preparation part. So far, we have seen the characteristics that affect adhesion. We also have seen which layers exist at the top of the substrates. Now we can discuss some general principles associated to the surface treatments and also give an overview of the recipes that exist. But before selection, which points should we take into account during the selection procedure? First of all, what is the initial strength that we want? Something modest, or we want the maximum strength? Does it need to be durable? Is it for tomorrow, or is it for 10 years, 20 years? 20 years, maybe we need something more elaborate. What is the initial condition of the substrate? Very oily or already clean? What type of substrate? We are talking about a polymer, a metal, a ceramic. We have completely different techniques, strategies for different types of substrates. And finally, of course, very important, production fighters. How long do we have? How much money do we have? This, of course, also will have an impact on the surface treatment that we choose. General principles. So there are three general principles. First of all, you might have material removal in a surface treatment. We are talking about oils and greases, oxides, dust, and release agents. Okay. Then you can have change of surface topography. In the case of metals, it's very easy to see when you shot blast or use emery paper, you have an increase of surface roughness. This is good for the mechanical theory. Let me show you, for example, this part, this substrate of aluminum. Here is very smooth and here is very rough. This was treated with shot blasting. It's very, very clear, the change of topography. You would have also a change of topography, easily seen with eyes if you apply emery paper. You have also, you might have the capillarity effect. This is what you have, for example, when you apply acid treatment to aluminum. This is the way it looks after acid treatment, so it changes color. But if you zoom a lot this with a scanning electron microscopy, you will see a porous structure, and the adhesive can penetrate into that pores and by capillarity and have a mechanical anchoring. We are talking about the mechanical theory and here as well. Finally, you might have the modification of the surface chemistry. Oxide formation in the case of metals, like this part here, the anodization or acid treatment will form a new oxide at the surface, very strong and very durable. You have an increase of surface energy in the case of polymers. When you apply plasma, for example, this will increase the surface energy as well as increase the polar bonds. It will break the chains will react with water, and this will create polar bonds. So, depending on the complexity of the surface treatment, you might have 1, 2, 3 general principles. If you have something very, very simple, for example, acetone, only 1. If you have emery paper, you have 1 and 2. If you have anodization, you have 1, 2, and 3. Okay? The more complex, the more principles are involved. Okay, you can divide or classify the surface treatments or the processes in two. You have the passive processes and you have the active processes. What does it mean, passive and active? This is related to the chemistry. If there is not chemical change at the surface, then it's a passive process. If there is a chemical change, then it is an active process. In the case of the passive process, basically you just clean or remove the substances. In the case of the active process, no, it's more complex. In the case of metals, you are trying to form an oxide, well-known, controllable and durable. In the case of polymers, with physical treatments, you are going to increase the surface energy and create a surface that is more polar. Of course, this is the last treatment when you want high strength and durability. And finally, you have here in this slide an overview of all the recipes, all the surface treatments that exist for passive processes, for active processes, but we are going to discuss in more details a few of them in the next module.